Hi everyone. Today I want to talk about theoretical and experimental probability. Now, theoretical probability is what should happen. So, theoretically, if I have a number cube and I roll that number cube 6 times, theoretically it should land on 1, 2, 3, 4, 5, and 6, because theoretically the probability of it landing on one of those numbers is 1 out of 6. But if I performed an experiment, or I was looking at experimental probability is what does happen when an experiment is done. So let's say I would roll that same number cube maybe 12 times. And so when I rolled it 12 times, it only landed on the number 6 one time. Well, experimentally, that would have been a 1 out of 12 chance. So experimental is what does happen. Theoretical is what should happen. Now, with experimental, the more experiments you perform, the closer you will get to theoretical. So let's take a look at some examples. The first one, a coin is tossed 20 times. It lands on heads 9 times. Compare the experimental and theoretical probabilities. If they are not close, give a possible reason for the discrepancy. So my experimental probability is 9 out of 20. That's what happened when I flipped that coin 20 times. Theoretically, when I flip a coin, I have a 1 out of 2 chance. So theoretically, 1 out of 2. Experimentally, it was 9 out of 20. Now, in this case, 9 out of 20 is close to 10 out of 20, and again, that would be half. So this was pretty close. Again, the more experiments that you perform, the closer you will get to experimental. Number 2, Jeremy has 4 cards, one of each shape, a triangle, a heart, a circle, and a square. The heart is randomly chosen 7 out of 12 times during an experiment. Again, compare experimental and theoretical. If they are not close, give a possible reason for the discrepancy. So again, experimentally, I got hearts 7 out of 12 times. Theoretically, I have 4 cards, and one of them is a heart, which would make theoretical 1 out of 4. Well, 1 out of 4 and 7 out of 12, if this were, even if I had 8 out of 12, that would reduce to, let's see, it would reduce to 2/3. So that's not really close. So not close. And again, what would be a possible reason for the discrepancy? And maybe we should perform it a little, a little bit more often, or perform the experiment more times. So maybe if we went another 10 times, we might get closer to that theoretical. And a lot of times we don't really know why that happens, but these two are really not that close. And then on number 3, when playing a board game, Marisol rolled a number cube 10 times. She rolled an even number 7 of those times. Based on her results, what is the experimental probability that she will roll an odd number on her next roll? Now again, we're looking at experimental. So experimentally, she rolled an even number 7 out of 10. Okay, so if she rolled an even number 7 out of 10, that means that 3 out of 10, it was an odd number. All right, 7 out of 10, it was even. So experimentally, the probability of her roll being an odd is going to be 3 out of 10. Okay, and that's all experimental and theoretical probability involved. It's just in one, it's what should happen. In the other, it's what does happen. Make sure that you fill in your Google form, and if you have any questions, bring them to class tomorrow.